some of you are missing. Then you have to plot another graph of PR3. Okay, so how am I going to do that? I'll just plot it briefly. So that's there.
Yes, can we do straight line?
It's there. Oh no, 120 should be here. And then at 200, it's 0.006, which is there. 360, it's 0.0028. 246, 2468. Okay, so my graph looks something like, oops. Now, when you draw it says line of best fit. It looks like a straight line. Did you get a straight line?
Yeah.
Okay, let's see. Let me have a look. Make sure you label your graphs, okay? Yeah, it should be a straight line, okay? The one that you did in question 4, 9, and 10, it was actually a curve, but some of you draw a straight line, okay? That's why your numbers were a bit off, okay? I've marked some of the papers, but some of them I haven't, okay? So later on, please check your feedback, right? If possible, do correction. Right. So you label. So I am missing, let me just search. I am missing Isa, Kawi, and Ben. Right? Let me just double check. They're not here, right? Isa, Kawi, and Ben. Okay, so I will label this as my PR3. Okay, so this graph is a bit different to the graph that you have saw before this, because the one before this, the concentration is specific for a specific reactant. Oh, Ben needs a password. Okay, hold on. How do I check the password? Hold on. Yes, I see Kawi. Hello, Kawi. Hi, Ben. Okay, you may unmute your microphone. Oh, I don't see them yet. Ben, you may unmute your microphone because we're doing questions anyway, and I don't want to be talking to myself. So we started plotting for question 8, okay? For the two of you who just joined us, Kawi and Ben, basically this graph is a little bit different because if you look at the axis, it only says concentration over time, but it doesn't say concentration of which reactant, okay? Chromium or the PR3, and it seemed this graph is different in a way that you have two different graphs for two different reactants, okay? So this is chromium complex, I'll just call it chromium complex, and this is the phosphorus ligand, okay? And it seems that after plotting, it looks like it's a straight line, right? Isa needs help. Hold on. Okay, so start plotting. If you haven't, Kawi and Ben. Seven 79328 because Zoom is now like upgrading their security. That's why I don't know how it works though, but I now can allow or deny you to join the session, as opposed to what before this you can just join in anytime. I mean, not anytime, but you can just join. Anyone can join in, anyone with the link. But there's also that I read about the security of Zoom, how, you know, hackers can easily penetrate through or something. Okay. So first plot the data using the same axis, scale, and draw the best fit line. Now, when they say best fit line, it doesn't mean that it's a straight line, okay? Line can mean straight or curve. So this is one of the common mistakes made in your previous exercise. I mean, in your previous work for question 4, 9, and 10. It was actually for a curve, but you draw it as a line, okay? So best fit line does not necessarily mean a straight line. A curve is also a line, okay? Use the graphs to determine the order of a reaction with respect to chromium and phosphorus. Now, this one is easy, I think. From the graph, it's a concentration time graph. You can spot it easily, especially for PR3, because it's a straight line. Does that ring a bell for you?
Yes.
Yeah, okay. So there's only one order that has a straight line in a concentration time graph. Okay, so that tells you PR3 is 0 order. Okay, for chromium, I know it's a curve, but remember, first order and second order are both curves. So you cannot just assume that the first order, because it's a curve, you assume that it's the first order. No, you have to do some calculation. In each case, explain how you arrived at the answer. Okay, for PR3, it's easy, right? Because PR3 is a straight line. That means, what do we know about the straight line? There is no change in rate, okay? Even though the concentration is changing, the rate is the same. You take the rate at concentration 0.01, it's the same. You take the rate at 0.006 is also the same. You take the rate here is also the same, okay? Rate is the gradient of your concentration time graph. So to explain PR3 is 0 order because it is a straight line. And to explain it further, the rate does not change as your concentration change. Okay, I repeat, PR3 is a 0 order because it's a straight line. And if you want to explain it further, the rate does not change as concentration changes. Okay, so PR3 is out of the way. Can we move on? Are you still writing?
Okay, sir.
Okay.
Okay, miss.
Okay, Kawi, nice to hear your voice. Al, okay? Mirza?
Yes.
Mukri?
Yeah, okay.
Nick? Nick just joined. Iqbal?
Yes.
Okay. Kawi already. Ben? Ben is still muting. Ben is muted. Ben, you okay?
Yeah.
Graph already plotted?
Yes.
Okay. Isa? Haven't heard Isa's voice. Isa, are you there doing this exercise or are you there sleeping? She's not answering.
Yes, baru termasuk.
Then she must be sleeping. Have you plotted your graph? Isa?
Yeah.
Okay. I believe you, although it doesn't sound convincing.
Hello.
Right. Right. Now, if we want to, now for chromium, okay, so chromium, you have a curve. Hold on, someone is chatting. Where's the chat box? Chat. Miss, can you hear me? Yes, I can hear you. I can hear you, Isa. But maybe a little bit lagging. Okay, now, so a curve in a concentration time graph can mean two things. Second or first. You cannot just assume it's first order. And there are two ways to determine the order of reaction. The first one is what happens to the rate as you change the concentration, okay? That's the first method. And that is fine, but it's it takes more things to do or more calculations. The second method is half-life. Okay, what do we know about the half-life of a first order reaction? Constant. Okay, so you can find the half-life for chromium complex. Well, I just gave you the answer that it's first order, but still, even with the calculation of half-life, I still see some people getting confused with their calculation. Okay, so always start with the starting concentration, the easiest 0.01. Half of that is 0.005. That's the easiest. Okay, so now why am I drawing it on chromium? Because I only want to know the order of chromium. Okay, in your previous exercise, you have two graphs and you got confused as to which graph you use. You just have to choose one of the graph. Okay, you don't have to draw the graphs for both. You don't have to find the half-life for both. Okay, the half-life will be different but constant for different graph. Now in this case, we want to find the order of chromium, so if we draw the line for a half-life for your chromium. Someone is annotating. Don't disturb. Who is that annotating? So 0.005, half of that is 0.0025. That's that's 3. So the next half-life would be somewhere here, I'm guessing.
700.
Okay, so somewhere there, and then it has to hit the curve. Okay, and then you draw a straight line again. Okay, so you actually just need 2 half-lives is enough. 2 half-lives is this they want to join also, even though I said it's optional. You can sleep at home, Eric, Kai Xiang, and the others who joined. But thank you for joining.
I miss you, Miss.
Ugh, please. We know one person who doesn't miss me.
Kai Xiang miss you also.
Oh, thank you, Kai Xiang. I know one person who doesn't miss me. You know who? Yeah, Okay, so you just need 2 half-lives. This is your first one. Apa kan to? What is that? Okay. Right, so that's the first half-life, and that's the second half-life. That's it. That is all you need to find for half-lives. If you have two graphs, just choose one and focus on that one graph only. Because this is what sometimes I see, say you have graph A and B, you find the first half-life from graph A and then the second half-life from graph B. That doesn't work. Obviously, you will get different numbers, okay? And then some of you don't want to start at 0.1, okay? For example, you start at, I use a different color. You start at, say, 0.08. What are you doing, Isa? Okay, right. That's not a nice straight line. So you say, for example, you want to start at, that's a funny straight line. You want to start at 0.08. Okay, fine. Half of 0.008 is 0.004. Okay, fine. I'll draw that. Okay, now you see, actually your first half-life is this portion. How do I erase that? Okay, this part is not half-life yet. Okay, this part from 0 to 220, that's not half-life. Why? Because you go from 0.01 to 0.008. That is not half. That's something else. Okay, so that's why if you tend to get confused, you just start from the initial number, 0.01, easier. Okay, don't start at a different point. Even though I said yes, it doesn't matter where you start, but you will get it confused anyway. Okay, right. Did you manage to find your half-life?
Yes.
What did you get?
700.
Sorry, 700? Yeah, 700 sounds about right. So it should be more or less constant. Different a bit. Sometimes you will notice that your half-life will be a little bit different. But, you know, if it doesn't change so much, then you would just say they are more or less constant. Okay. So in this case, you found your half-life to be 700. So that means the order with respect to chromium is first order. Okay, mention also to explain. Okay, first order is just stating the order. You need to explain because the the half-life is constant, which is around 700 second. This is in second. Okay, another thing that I noticed is that some of you, because in the graph, they use minute, right? And then in your calculation, you convert it to second again. That is fine, but it's additional step, okay? If you want to use minute, it is fine. You just follow the question. Unless the question say, write down your units in per second, okay? Then you change it to second. Otherwise, you just, you have additional step, which is to convert the minute to second. If you do it right, fine, okay? But some people did not convert the minute to second correctly because they multiplied by 60, but actually the second is the bottom term in the expression, okay? So you have to be careful. Otherwise, to be safe or to be quick, you just leave your answers in minute. In this case, they give you the time in second. Okay, so that tells you PR3 is 0, chromium is 1. You need to write the rate equation for the reaction and calculate a value for the rate constant. Okay, so this is again another thing that well, this is what you tend to get confused. So my rate is equals to K times by the concentration of chromium. Yeah, that's all. PR3 does not appear in my expression, okay? So they want you to find the value of the rate constant. So they want you to find K, okay? Now, rate, how do you find rate? Yes, the gradient. And the easiest, okay, the easiest is you take the initial rate, okay? Initial rate. Now, PR3 is out of the question already, okay? We don't deal with PR3. So I'm going to erase everything now so that you don't get confused. Nice also using preview for drawing graphs and whatnot. Okay, so the easiest, of course, you can take the rate at any point, no problem. I think I should, okay, I should leave the PR3, okay, right. You can choose at any point, of course, okay? But for me, the easiest is at the initial. So I'm going to use a different color, blue, for my gradient. Okay, I hope you all know how to draw the tangent at 0, right? And you know what I like to do? I like to extend my tangent to the x-axis. And this whole thing, this triangle is already my tangent. Easy. This, what do you call that? Coordinates. This coordinates is 0 and 0.01. This coordinate is 940, I think. 940 and
Yes.
0. Yeah. So you don't have to draw, some of you I saw you draw smaller triangle like that. Just use the big one. It's easier. And extend it to the, some of you, I see you drawing this and then you read off again from this point to this point. This is quicker. You extend it as long as possible until you hit the x-axis. Okay. So you find the rate from there, and you will tell me later because I don't want to calculate. And the concentration of chromium complex. Now the concentration is where you take the rate. Now in this case, we take the rate at t equals to 0 and initial concentration is 0.01. Easy. I hope so. Okay, so the rate is from the gradient. The concentration of chromium is 0.01 because that's the initial. If you take the initial rate, you also use the initial concentration. Is it easier to have a big triangle? Easy, right?
Yes.
Yes. Okay, and then you work out the units. Don't forget, the units for rate is mole per dm cube per second. In this case, we use second because in the axis they use second. So I'm just going to blue. And the unit for chromium is mole per dm cube. Okay, you carry that onto the other side because you want to find rate constant. The question asks you to find rate constant. Okay, and then you carry this over to the other side. So the mole per dm cube should cancel out. Ugh. I can't believe one question is like 40 minutes. Zoom is already telling me that I have 10 minutes left. There is another method to find K. Can anyone suggest?
Using half-life.
Yes, half-life, that's right. What's the formula again? I forgot. T half is equals to ln2 over k, is it?
Yes.
Yeah, you can use that. It's much quicker as well. Okay. Does it say anywhere, right? Oh, yeah. Oh, using the method of initial rates or any other method you prefer. So you can actually use this. Who is that? Yes, Kai Xiang. Thank you, Kai Xiang. You can use this T half is equals to ln2 over k. So for this question, they give you option, right? They say you can use other method as well. But if they say using initial rates, then you have to use this method. Okay. So T half, you already got it as 700, I think, if I'm not mistaken. So you just rearrange your k, ln2 divided by 700, then you should get the answer quickly. Is your answer, what is your answer? It should be around 9 times 10 to the power of minus 4. Around that. Okay. Don't forget your units. What's your units? Apa net? Apa? Apa unitnya? Second? Minus 1.
Yeah.
Yeah. Ben, yours is, yeah, that's fine. 1.06 times 10 to the power of minus 3 because it's close to 9 times 10 to the power of minus 4. Okay. So the unit is second to the power of minus 1. And then we move on, state the units of the rate constant. We move on to the mechanism. 4 possible mechanisms for this reaction are given below. Draw a circle around the letter next to the one mechanism which is consistent with the rate equation. So in your rate equation, you only have chromium. So that means you have to choose a mechanism that only has chromium CO6 as the slow step. Which one is that? A, B, C, D. Chromium CO6. Don't get confused with the chromium CO5. We are looking at chromium CO6 that is in the slow rate determining step. A, B, C, or D?
B.
B. Yes, the answer is B. Okay, so if you look at this, B, CrCO6 is the only one in the slow step. Okay, so the answer is B. Explain your answer. How to explain your answer? Mechanism B is consistent with the rate constant. Only CrCO6 is involved in the slow step. That's already your explanation. Okay, I repeat, only CrCO6 is involved in the slow step. It cannot be D because you have both. For D, you have both this PR3. PR3 is not in the rate equation. As for A, CrCO6 is fast, which is not the rate determining step. For C, they don't tell us which one is the slow, which one is the fast step. Okay. Also in C, you see that there's chromium and the PR3. So one of your possible explanation is to say it is the only one that doesn't have PR3 in the slow step. Okay, so you can either explain it by it only has chromium, or you can say it doesn't have PR3. Okay, now I actually intended to do question 7, but it seems like that's not possible. Actually, I wanted to choose a question that was similar to question 4, 9, and 10, but I'll have a look at it first, and if I can find But please check your feedback, okay? When I tell you that I've already marked your paper, please check it. Restart call. What? No, you have class after this.
Block 1, yeah.
Block 1. Does everyone have free block 1?
No.
Yes, not everyone. Some people have maths. DNT. See, Ben has DNT. I don't want his DNT tutor to be mad at me.
Can skip.
Hey Ben, skip. Okay, that's fine. It's enough for today. Maybe I'll talk. I'll pick one question from the exercise that you did, because a lot of you confuse, especially working out the order. Okay, working out the order of one reactant and then the other reactant. For this one, it's easy because you can see that there are two different graphs. Okay, any questions before we end the session?
No.
Is it clearer now?
Yes.
Okay, I hope so. All right then. Thank you, everyone. Bye, everything.
Thank you, Miss.
You're welcome.
Yeah.
Bye.
Thank you, Miss.